The sun, ordinary, blazing, 93 million miles away, doing exactly what it did yesterday. Now imagine, with no warning, right now, it collapses into a black hole. Same mass, same everything, just gone dense. Your gut reaction is immediate. Earth gets dragged in, torn apart, swallowed whole. But is that actually what happens? Because here's the thing. The scarier question was never really about gravity. It's about what that ordinary yellow star quietly does for you every single second without asking for credit. Nearly everything alive on this planet, every meal, every breath of oxygen, every calorie that ever powered a heartbeat traces back to sunlight hitting a leaf or an ocean surface. One star, 93 million miles away, running the entire show. The real answer to what happens when it vanishes is stranger and more important than the fear you just felt. So let's start with what gravity actually is. It's tempting to think a massive object pulls on you because it's big, because it looms, because it's enormous to look at. That's not it. Gravity depends on one thing only: how much mass is packed inside and how far away you are from it. Picture the sun's mass as a fixed amount of stuff. Right now, that stuff is spread out into a sphere nearly 700,000 kilometers across, so vast you could fit over 1 million Earths inside it. A black hole doesn't add any stuff. It just squeezes that same amount into a point smaller than a city. So here's the first question worth sitting with. If the sun collapsed down to a single tiny point, wouldn't Earth suddenly get pulled in closer, sucked toward it? It feels like it should, but the answer is no. The pull you feel from any object depends only on its mass and your distance from it. Not its size, not its density, not how frightening it looks. Squeeze the sun down to 3 kilometers wide and Earth is still 150 million kilometers away, and the sun's mass hasn't changed by a single gram. Which means the force holding Earth in orbit is, at this exact distance, identical to what it is today. Earth doesn't spiral inward. It doesn't feel a stronger tug. It just keeps doing what it's always done, circling on schedule at the same 107,000 kilometers per hour, tracing the same 365.25 day year. Only now it's orbiting something you cannot see. And that's where it starts to get strange. Because the orbit is fine, the mechanics are fine, but everything else is about to fall apart. The first thing you'd notice isn't gravity at all. It's the sky. The sun is gone, not dimmed, not eclipsed, replaced by a perfect silent black disk, a hole in the sky that emits no light at all. Because a black hole this size emits essentially none. You wouldn't even see it as an object. You'd see nothing where something used to be. But here's where it gets stranger still. Within hours, plants stop photosynthesizing. That's the process by which sunlight gets converted into the sugars that feed nearly every food chain on Earth. And without photosynthesis, that entire mechanism just switches off, everywhere, all at once. Within days, the base of the food web begins to collapse. Phytoplankton die first, and everything above them, fish, birds, you, was only ever borrowing energy that originated in a leaf or an algae cell, converting starlight into sugar. Cut the light, and that whole chain starts unraveling from the bottom up. But here's where it gets colder, literally. With no sunlight warming the surface, temperatures begin collapsing toward the deep ambient cold of space itself. Within about a week, surface temperatures could plunge below anything in recorded human history. Within roughly 2 months, the oceans begin freezing, not from the bottom, but from the top down, sealing in whatever heat remains underneath like a lid. The deep ocean, with its enormous thermal mass, would take far longer, perhaps 1,000 years, to freeze solid entirely. So something would still be liquid down there for a very long time. But it keeps escalating. Eventually, months to years in, the temperature drops so low that the atmosphere itself stops being a gas. Around -180 degrees Celsius, oxygen turns to liquid. A little colder, nitrogen follows. The very air starts to rain down, and then snow, gently, onto a frozen, lightless world. So, could anything survive this? Almost everything on the surface and in the sunlit ocean would not. But deep on the ocean floor, there are ecosystems that never depended on the sun to begin with. Communities clustered around hydrothermal vents, feeding on chemical energy from the Earth itself, not light from above. More than 500 of these vent fields have been found scattered across every ocean basin on the planet. Down there, in the permanent dark, near boiling mineral-rich water still rises from the planet's own interior heat, and organisms have been thriving on it for eons, entirely independent of any star. If life persists anywhere on a lightless Earth, it's there, in the one place that was always, in a sense, already living without the sun. Which brings us back to the beginning. So, does Earth get pulled in, torn apart, dragged toward the black hole and destroyed? No. Earth's orbit is untouched. It keeps circling on schedule, exactly as it always has, only now around a point of absolute darkness where a star used to be. The gravity was never the danger. You couldn't have really felt the weight of that answer a few minutes ago, not before watching the sky go dark, the plants stop, the oceans freeze, the air itself fall as snow. Now you can. The black hole doesn't reach out. It doesn't grab or pull or hunt. It simply gives nothing back, no light, no warmth, no information at all. And it turns out that absence alone is enough to end nearly everything. Because the danger was never that something might come and take Earth away. It was that something might stop giving. Every version of this disaster, the failing plants, the dying oceans, the falling air, comes from a single missing ingredient: light. Not gravity's presence, but light's absence. And that's worth sitting with for a moment, because it means something quietly enormous about the world as it actually is. Right now, today. Nothing alive down here generates its own warmth from nothing. No creature invents its own energy from scratch. Every calorie in every living thing on this planet is, in some sense, second-hand sunlight, captured, stored, passed hand to hand through billions of years of life, one borrowed photon at a time. You are, this very moment, running on light that left a star 8 minutes and 20 seconds ago. And that light itself was made by fusion in the sun's core tens of thousands of years before that, slowly working its way outward before it ever escaped toward you. It's an old, patient, quiet kind of gift, and almost no one ever stops to notice it's being given at all. So look up, if you can, at the ordinary, unremarkable, blazing sun still hanging exactly where it always has. It isn't going anywhere. The real sun doesn't have nearly enough mass to ever become a black hole. That fate is reserved for stars far larger than ours. It will simply keep burning quietly for billions of years yet. It was never just decoration in the sky. It's the reason there's a green planet to look up from at all, the reason there's anything here worth calling life. That's not a small thing to carry with you the next time you step outside into an ordinary sunlit afternoon. We'll keep asking questions like this one, the quiet, obvious things hiding enormous ideas. For now, the dot keeps turning faithfully in the light. Small blue dot,